Okay, all right, let's look at another example. All right, so here's an example where I'm doing something kind of a little different to it, right? I've got my parent function is, as we know, is this, and that's the one we did in the last video. But this one, I'm subtracting 5 from it inside the absolute value brackets. So, like always, I am going to make my table. Okay, so I'm going to go x. I'm going to make this one kind of big, and you'll see why in a second. And then put this here. Let's leave a little bit of work room, and then we'll put this here for my y. Okay, so what I want you to think about here is, all right, so we're going to put in some numbers, and we're going to see what happens. All right, so if I put in 1, right, if I put in, or 0, sorry, I don't know why I said 1. If I put 0 in, I get 0 minus 5, which is equal to the absolute value of negative 5. And we know that the absolute value of negative 5 is 5, right? So I get the point 0, 5, right? So I go 0, and I go 1, 2, 3, 4, 5, and I go up to 5, and I put a point, right? Now I am going to go put 1 in, right? And 1 minus 5 equals absolute value of negative 4, which is 4. And it appears that what we have is we have something kind of a line that's sort of going down here. And if I put a negative number in, right, you're going to get negative 1 minus 5, which is equal to the absolute value of negative 6, right, which gives me 6. So negative 1, 6. So I definitely got something that's trending this way, right? And so, but let's keep going this way with it, right? And let's kind of look at what happens. Well, as I get closer and closer to 5, right, that this number in here gets smaller, right? And it's getting closer to 0, right? It's actually getting bigger. It's getting closer to 0. So this is the absolute value of negative 3, so it's 3, right? So we got the 0.23, which puts me here. If I use 3, and I know you're thinking, well, he's picking a lot more points than he did in the past, and yeah, you're right, but you'll see why in a second. Absolute value of negative 2 is 2, all right, and then when I use 4, right, I'm getting closer and closer to 0 inside there, right? So you get negative 1, and then we have 5, and 5 gives me 0. 5 minus 5 is the absolute value of 0, which is 0. All right, great. So it's very tempting, like we said, to kind of just say, okay, I'm going to make a line that sort of goes like this, right? And it just keeps going. But watch what happens when I put 6 in. When I put 6 in, check this out. You have 6 minus 5, which is the absolute value of 1, which is 1. So I got the 0.61. When I put 7 in, I'm going to have 7 minus 5, which is the absolute value of 2, which is 2, right? So this thing starts crawling back up. So the moral of the story is this is still the classic V-shaped absolute value function. The difference is it's shifted. And how you can tell it's shifted is this negative 5 acts as a transformation. It's a translation. It moves, it shifts the graph over 5 units, right? And so I can see that, right, by what just happened there. Well, it shifted the graph over. So absolute value equations are always going to look like some sort of variety of this. They can be upside down, and they can be wider or more narrow, but they're going to always look like a V at some level, even if the V hasn't shown itself to you in like your part, right? So this again is another example of just how the parent function shifts, right? And it's got the same slope as the parent function. It just moved over 5 units to the right. All right, so hope that was helpful. I'm going to stop the video, and we're going to have one last one.